today we're going to talk about schematic. Well, not necessarily a schematic, like how you can create component, and especially the schematic part of it, like how you can basically have a symbol so that whenever you're trying to draw your design, I always feel like any of the Altium or any of the KiCad or whatever how you spell it, whenever you create a schematic, you are telling yourself that I want to draw a picture of my grandparents' house. But first, I need to know where the chair should be, where the window should link to, where the bedroom of my grandpa is. Like, this is it's like you're building the stories before you do your drawing, right? So schematic is kind of like that. But every part of the stories has some kind of components, right? Even on your drawings, you have a room, you have some kind of doors, you have some kind of like nice beds, flowers around, right? So in the same way, in Altium, even in the electrical design, the components are basically some kind of elements that makes your design or you makes your art so beautiful. So we're gonna talk about how you can create the components, and definitely we're gonna show some of the important part of it. And as I mentioned myself, is that I'm not expert, but I'm a learning person. I'm learning, so I'm kind of like in a way to teach myself. So if I make a mistake, please just write something in the comment box. I will definitely highly appreciate it. So today I decided to go with this single pull double throw relay design, and it's from the Analog Device. I mean, these people are very good at making this kind of relays. I personally use some of their relays for my own work project too. They're very good, but a little expensive sometimes. But sometimes they are not too much expensive, but it comes with a cost. But one part of the Analog Device I like is they also provide you this S parameter, which is very helpful. Like when I try to do a simulation on the key side areas, I really need this thing, man. I mean, I definitely need this parameter. And this is something they're new, ADI Sim RF. I never used it. Maybe this is probably one of the great things they have. But I'm gonna do this, okay? And as you can see on the design, it seems like I have a RF1, I have a RF2, and then I do have a RFC here, which is a common. And this is basically the one that's going to make a decision whether your signal is supposed to go from here up here. Your signal is supposed to go from here to here, here to here, and sorry, this is the controller which will make the decision for you, and this is the common signal that shares both of them, right? I mean, this is very small and very silly, not so silly, but a very easy data sheet diagram. So before we dive into it, I just wanna show some of the important thing of a documentation before I do the schematic part. Then we'll talk about how you can do the footprint later on. So let's click on this data sheet and let's go. I mean, you are definitely gonna read this thing, right? This is some of the important part that you should definitely cover, but never forget to read this part. I mean, this is my favorite. One of my favorite is typical application circuit. Oh my god, I can emphasize enough that how important it is. It helps you a lot to understand that why you need this component, right? But if you're trying to do your footprints, definitely this part, the outline dimensions, is going to help you to do your footprints. But since this video is only going to talk about the symbol, how you can create the symbol on your schematic, I don't think we should care about it for now. Maybe in the next video, right? So hold your beer. We're gonna talk about it later, right? So let's go to Altium, probably, right? We shouldn't spend too much time around here, because I don't think that's very important for this video, at least. Okay, so let's go to Altium, and we're kind of working with this schematic and some of the layout. I haven't finished the layout, by the way. I should make a video about how I'm finishing the layout, because I haven't done it yet. But we are going to copy the name of this component. So if I go to this, I'm going to just copy the name, and I want to tell you something is there is many ways you can get the component, and there's many you can get the schematic too. I mean, definitely there is a lot of online resources around that helps you to find your component, right? Like if you go here and then say, hey, ECAD models or something. If you write down, ignore all of the news is kind of showing in my browser. They just always do it. Oh my god. Okay, ECAD models here. Or you can definitely go to like some of the ECAD models from DGKey or Alta Librarian or things like that. They're going to help you to find your component or whatever you need, right? Well, definitely not this one. But this video, I'm going to talk to you about how you can create it manually. So definitely don't take any help from any of the DGKey or some others. So if I go to the Altium, and if I go to my panel, and if I go to my, well, component, sorry. If I go to my component, for example, and if I get rid of this, if I click on here, if I just pass to there, and if you go to this find manufacturing per source thing, and if you click on there, this probably will show you, right? I mean, it's definitely telling you, hey, it's from analog devices, and it's saying for gig, mags, and 1 dB insertion loss, and some other good information that you need, definitely you need. And then the easiest way is probably like click on this model, like here, and then maybe choose, since it's a relay, I'll probably just choose relay. I don't know if it's a relay or switch. That's kind of a good question, right? Oh, it's saying switch, so it'll be a switch. It's not a relay. So click on switch, and if you click on OK, this is probably the easiest way you can create your schematic if you already have some of the information available, right? They're going to give you the footprint and some schematic design as well, and you can just go and add them in your. They're already probably added, right? So you don't have to worry about it. And so A, B, C are important. It's basically show you that different version of it. I might just go with maybe B for now. B is most of the time is the nominal one. So it basically means that based on your soldering system, it will have different types of footprint. Like sometimes your pads are a little wider, so that when you try to do a soldering, it helps you to flow your solder much better. Sometimes you have a very tight component and tight board, and you want your components to be very tight, so you don't want to have a lot of space from one particular component. So in very tight situation, you want to follow the exact recommendation from your vendor, right? And that time is good. It kind of depends on your soldering capabilities, right? So I'm just gonna go with the number B because I feel like mine is maybe nominal. I don't want to have so much space. I don't want to have too low a space. Oh yeah, I'm okay with both. And then on the parameter, definitely it's a very good thing as well. And you can just click OK, and that's definitely going to like create a schematic and a footprint and everything for you very easily, right? This is not a big deal in terms of making one. It's super easy. But it's kind of cool part, if you just go here, it's kind of cool part is they give you so many grounds. Oh my god, look at the grounds here. Oh my godness. Like, hey, if you guys know like why they have so many grounds, I would really highly appreciate you if someone please tell me why they have so many grounds. Like, look at this. Oh my god, so many grounds. Oh my godness. I mean, I definitely understand that you have to supply a voltage, you have a control voltage, you have an RF1, RF2, RFC, right? And I don't know what this EPAD is. It's maybe supposed to be, I don't know about the EPAD thing, but I don't understand why they have a lot of grounds. I just choose this component randomly just to show the video, and now I'm shocked by seeing a lot of grounds. Maybe there is something, probably a reason for it. I'm not really sure. As I mentioned, I'm a very newbie about it. Okay, so let's not really bother. But this is a one easy peasy way you can create a schematic and your footprints. But today we're gonna also talk about how you can create your symbols, right? So to create your symbols, we are going to do something different. We're gonna close this out as we don't care about it. And now we're gonna say, go to your top design, for example. And now you can go to your panel and you can go to your components. And then when you charge it, you can just do create component. And when you click on create component, it's gonna show and it's gonna tell you, please tell me what kind of component it is. Now we gotta choose either relay or switch. And as I was mentioning about, we're working on switch. So we're gonna click on switches. And after clicking on switches, you're gonna say, okay, right, it makes sense. Then this fun part comes in. My recommendation. So always fill things out. Please do it. It's very important. And in the part choice, always add your component so that it knows how much price it is. So whenever you trying to create your BOM, like BOMist or bills of material, it can tells you how much money it is. And if you're a poor person like me, and if you're broken, so based on the price, you'll be like, oh no, this is super expensive, I can't afford it. But if you're working with a big company and your company is funding your components, that's probably not a problem of having a lot of money. But sometimes you have to be a budget friendly or in a tight budget. Okay, so let's the easiest way, and which Altium does it sometimes, is if you write down the name. Altium does a great job here. He's gonna tell you, oh wait, you know what, I found a component. And when they say you find a component, you get excited, and you should be excited, because if Altium does find a component from Octopart, then it's gonna fill the rest of the information here, and then it's also gonna show you this part as well, datasheet as well. But right now we don't really want this thing for now, and I'm not gonna add a lot of symbols as well, by the way. I just don't think it makes sense having so many symbols. Definitely parameters are important part. I don't know about the research compliant things like that. I'm just gonna add all of them, whatever I need, and I'm gonna say okay, do it. Now this thing has been added in the part choice, so it's gonna help me to know the price, and you definitely can see it's $42. So think about even a date. You can probably have a dinner with your girlfriend with $42, maybe. Yeah. A lot of price. So it's kind of up to you. Do you want to buy a relay or switch, or do you want to impress your girlfriend? So choose one, brother. Now in here on the parameter side, some of the information has been filled out and pretty good, but I'm not really happy about how they didn't fill out your current ratings and case and mean operating temperatures, mounting technology, pins. They didn't really feel a lot out of it, which is kind of a little annoying. But the good part is the description looks very nice. It's like a diverse, like well, you know what? They say 1 dB insertion loss, but when I went to the datasheet, they were talking about 0.7 dB, if I'm not wrong, which is like, I don't know why they do it. Should I trust is 1 dB or no? Like this one is saying 0.7 dB at 2 gigahertz, right? It might be for 4 gigahertz or something. They might have like a 1 dB insertion loss, I guess, but I don't know why they say that. Wait. Look at this. Now they have it. Well, yeah, it was definitely 700 megahertz to like 4 gig. Whatever. Okay, we don't really care about it. But good part, our things has been filled out, right? And thus we really care about it. Now, the second part, so the last part of the video is to showing you how you can create a symbol. I know I've been talking about a lot about different things, because this is basically a whole series of how you can create components, and so on. I know this video is going to be large, so if you're watching till now, thank you so much. I mean, that really helps, right? Now, on the add symbol, you do still have two options, and widget is probably the easiest way you can create a component. Trust me. All you have to do is lay out a style and go and choose some of the style you're gonna choose. Maybe manual or maybe not. Quad size. If you do quad size, it's gonna be like this, which is pretty good for our switch type, right? And then you can increase the number of pins as well here. You can number of pins, then you can define them here. Like you can just say, no, this is going to be my paysafe, and this is going to be my something, whatever it is. Then you can also change the left or right bottom if you want to or not. Yes, with a widget is probably one of the most easiest way you can create a component, right? It's pretty cool. Thanks to Altium for having this widget. I don't know if you have more options. I guess that's all. You do have like this 10 and then designator. Display name is something you should probably write it down. So if your one is a ground, that's a ground. And if it's not a ground, it's not a ground. But remember, I don't know if you guys remember that. Like it has 32 grounds. Oh my god, that has a lot of grounds. When I download the symbols, I still don't know why they have so many grounds and why it's showing it so many grounds. My god, it's probably how the manufacturers designed it. But as I said, I'm a newbie. I don't really know a lot about it. So then make sure you can also do some kind of description if you want to. That's kind of up to you. If you do, that's great. If you don't, that's not great. Maybe that's still great. Okay, so I'm not gonna really talk about wizards because, as you can see, it's very easy, right? It's very easy to make any kind of wizards or thing like that. But what I'm gonna talk about is how you can do from here the new one. By the way, if you have some existing symbol, you can also click on here, and then you can load your existed symbols from your library or somewhere you want. I don't have an existing symbol, so it's not for me. It's not for me. Okay, let's go to the new. I know I'm almost 15 or 16 minutes of video, and we're just right starting the symbols. I'm sorry, but I feel like I should have talked about it. So I feel like it. Okay, the first thing to do is knowing your symbols and knowing your schematic. So if I go here, I have this functional block diagram. Great. Now, this is up to you. You can have a different kind of many alteration of your symbol. So what I mean by it is, if I go and create, for example, well, let's get rid of some of the little. Oh my gosh, my PC is not responding right now. See, sometimes it just does this crazy thing. Whatever is working right now, all of a sudden. Okay, let's go back. Sorry for that, guys. So we're gonna have. What is it? Wait. Boop. See, sometimes it's just too annoying. Let's go to the datasheet again. Yeah, here you go. Sorry for that. Let's create a rectangular here. Once we create a rectangular like that, now one of the important part before you create a rectangular is defining your grid size, and you can just go to the view option, go to the grids, set a grid snap. Maybe I will do how much? I will do 25. Okay, I will do 25 here. Okay, just because I have like 5 steps for each. I mean, what I mean is 25 plus 25 is 50. 25 is 100. So I have like 4 different sections to break down 100 mil of thing. So it's kind of helpful. Let's click on OK. Let's go and create a rectangular. So rectangular should look like this. I'm trying to copy paste whatever I have here. Then what I can do is I have to assign some pin, and the pin is super tricky. What I used to think is, oh yeah, guess what? It's linked here, but it's not. It's always the cross thing you see. That's the one you should be connecting like this, right? So what you're gonna do is you can do space. Now it's showing 5. I want to go with 1. Designator is 1. And oops. One thing you forgot to change is the name. Maybe I will give a name is well, if you want to see the naming of it, you probably be better off going to the schematic, the datasheet, and looking into the table. Here you go. Oh, I see why they have a lot of grounds. Look at this. They already was telling you that 1, 2, 3, 5 to 11, 13 to 20, 22 to 27, 30 to 32 are ground. But they didn't really explain why it is. Grounds package bottom has an exposed metal. Oh, it has exposed metal pad. So that's the reason they're using a lot of grounds. I'm sorry. I now get it. Why do we have a lot of grounds? Makes sense. I think it makes sense. But for this video, I don't think I'm going to create so many grounds like that. I'm just going to create 5 symbols for now. Or maybe I can create a lot if I want to, right? Maybe not. I'm just going to create like this. Maybe this. Like this, right? And I'm going to make one side all of the ground, other side probably the relays that I'm having. So what I'm going to do is I'm going to place a lot of pins. I'm going to say this is designator 1. And the name should be... I don't want to give any name for now. The reason I don't want to give a name right now is because I feel like the video will become so big. So maybe let's just say from here is we're gonna just choose 1, 2, 3 as a ground. So we're gonna say ground here, just G and D ground, and just like place 1, 2, 3, right? And then we're gonna do 5 to 11, so it'll be like, you can just change here to 5, and now you can do all of them are ground right here. 5, 6, 7, 8, 9, 10, and then you have 11, and then it says from 13 to 20 is also ground. That means you 13 here, and then you can just go here. That's the name. Sorry, that's the name. So you can just say 13 here. Now if I continue again, that should be ground as well. So make sure you have the name as well. GND ground. GND is ground. Continue. Let's keep going. 13 to 20. My god, guys, this is getting really crazy, right? This is getting super crazy. So 13 to 20 is your ground as well, so you can just keep going. And 20 to 27 is still ground. I don't know if I should cross the video, but if you guys want, you can just cancel it if you want to, but let's just keep going because it's not going to be too bad, hopefully. 24, 25, 27. There you go. Oh my god, look at that. It's like a gigantic of grounds all over the world. The ground is winning. The ground is the winner of the today's video. Okay, so I have 30 to 32. That's the last ground, I promise. I'm not gonna boring you. 30 to 32 is the last ground I have here on the video. So let's do 31 and 2. Almost. Oh my god, like, I swear to god, this is so many grounds around. Now you can also make your the rectangle a little bigger so that you can cover all of the components. I'm gonna make it a little bigger like this for a reason, because I want to have my comment here. Okay, so you can make it a little bigger like that if you want, and then just keep it here. And now you can just take this and bring it back to the middle. So that's kind of easy peasy. Okay, so many grounds around. Now we have to make the fun drawing. We have to decide what is our RFC will be. What should be our RF1 should be, RFC should be, RF2 should be, and BCTL and the VDD and others as well. I'm gonna do something cooler here. What I'm gonna do is maybe I'm gonna keep the RF1 and 2 this side and RFC this side. That's probably a very nice way to put it, right? And also you have some kind of like a place IEEE symbol. They are very useful as well. If we go to this section of the Altium, they talks about all kind of IEEE symbols to help you out with your, maybe you want active low input or active single in or AND gate or bidirectional single or delay, dot, or greater than or equal to, whatever. I mean, they have a lot of them. So just make sure you're using it if you really need to. If you don't really need to use them, I guess don't bother, maybe. So let's get back to our tedious job. We're gonna do 4. So let's create RF1 here. Let's create a pin. And let's put it here. And let's click on tab. Click on 4. 4 should be our RF1. So just do RF1. And now you can do some things here, like maybe I'm gonna just say paste it. Sorry, it's basically saying your symbol inside, how you want to represent it. Probably that's what it's saying. I'm not really sure should I do anything with that. It's nothing really like that, so I probably shouldn't care about it. But if you know you have to use some kind of symbols, please do so. Maybe it will help you. But I'm just gonna say bidirectional signal flow line with maybe a smallest is fine, I guess. And now you can just go here and just say RF1. And then for RF2, I have to go here and I'm gonna say tab RF2, which already be automatically written down. And this is pretty cool. And I want to create my RFC on the right hand side, which is basically a 12. So I'm gonna do is RFC, and this is gonna be my 12. And I'm going back here. There we go. RF12. So I have RF1, RF2, RFC, and then I have to give a VDD. And the reason I keep my ground here so that I can keep my power on my left hand side, I like to do this design in this way. Now I only have pin 28, pin 29, and that should be end of all of this scary crazy work. And now I can also go and change it to maybe a no symbol here. The inner edge, it's not a clock. Inside, not a pulse at all. Maybe it should be, I don't know, I should really even feel it out, but I'm just trying to figure it out, that is it really important or not. Well, let's just keep it as it is. Let's just keep it like a paste it without any kind of information. And I'm gonna just put this one here. I'm gonna say 28. The designator would be 28, and now this would be maybe BCTL control. Now just gonna place it 28. Then here I'm gonna keep my BDD, which is 29. Pretty good. BDD is 29. It's 20, pretty good. Now I guess we're done with the symbol thing right now. I want to show you something cooler here. Is you might also want to give some kind of name if you want, if any kind of text you feel like important. Maybe I can just say any of the stuff that I'm gonna say sorry for a long video. I'm gonna say sorry for a long video as a text. And I want to show you something more cooler. If you copy this, I guess you can probably copy it. I guess if you copy this, and if you go to your tools, if you go to the model, you can add a model. And you can just pass it to here. And the reason I'm creating a model here, because on this part I'm gonna be a little bit more expressive. I'm gonna do some drawing here. So I'm gonna do is I'm gonna say my thing is will be coming this side, and then this is going to be coming. Well, let's do this. Let's change the color at least. So let's change it to blue. And let's make the solid, solid is pretty good. And let's make the size to a small. I think a small is already there. So let's keep it as it is. And then let's draw the same. Well, we still have to change the color, which is a little annoying to have to keep doing it. And then let's just keep it here as well. Let's do the same as here. And now, if you think this is by default connected to your RF1, the RFC, which you can tell from this, it seems like the RFC is by default connected to the RF1. So I can just do something like that. I can just go ahead and do this. It's not gonna let me, so I have to choose something different. Well, it's gonna let me if I do shift and space, see, it's letting me to do it. So pretty cool. So now you can just basically have this kind of symbol. Oh my gosh. Okay, let's do it again. Line, click here, shift, space. Here you go. So it's basically like helping you to show that is connected to this one by default. I mean, you can represent it much nicer way. And you can also represent those things as a ground. You can just be more expressive. And if you want to take it more further to show the whole schematic there, then you can go to the tools and you can go to the mode and you can just add another one, and you can show all of the things, all of the circuitries, internal things as you want. But for this one, I don't think I'm gonna show that because I don't really need it. Okay. Now the cool thing about the mood is you can just go back to your normal. You can see this. And if you go back to your alternate one, you can see this one. So as you keep making one, it just helps you to keep stacking up one by one, which I find very helpful and very fun as well. So that definitely helps. I don't think there's many more spatial stuff to talk about, but before I end the video, I think I'm gonna end up with a trick that I do. With a trick I like it, and which is if you think this is your power, I see some people doing it. If you think this is your power, some people they're very good people, by the way. They know how to make things more nicer, so they do this. So sometimes they just make some kind of like a round here, you see, and what they do is they just go to the properties, they click on transparent, they fill the color as well, they make it a little reddish looking. Well, this is not reddish, little reddish looking. And then what they do is they just take it there and put it somewhere around. Well, if you want to put it there, you have to probably change your grid size as well. So just go to the view, grid, set a global grid, maybe 5 mils is pretty good. Oh, minimum is 10 mils, so you can do that. So let's do 10 mils. Let's do 10 mils and see if we can fit it inside. Please help us to fit it at least. So yeah, so they just like go there, they just like make it a little reddish like this. So it kind of helps you to see, yeah, this is my power. And if you have ground here, they make it a little dark. So if you just copy it, and if you paste here, and you can just make it to like a little darker, the color. Like if I just go here, I don't know if I can do it. Here you go. If you go with dark, yeah, I guess that's work. Okay, whatever, it's not working. Maybe I should try my best to make it work. Oh, sorry, I was in the wrong one. So they make it like a little darker. So basically the reddish means your VDD and the dark means your ground. So that's the video. I know it's super huge. Like 31 minutes of video is like, damn, my God, I've been talking a lot. I should drink some kind of water. But if you really enjoy my video, please accept my apology for a very long video. But I will probably see you guys in the next video where I'm going to talk about how you can create footprints. And we're gonna have fun designing and maybe learning some tips and tricks as well. And since then, have fun. And also, by the way, all this kind of play around with this Bezier thing is super cool. You can draw any kind of cool stuff you want. I kind of like this Bezier stuff. So you can make your Christmas shoes around. You can draw a human if you want to. So play around with this cool part of the Altium and enjoy designing. See you in the next video.